Hi, good morning, good afternoon, and good evening, everyone. I'm Rob Mossy, and welcome to another Ask the Experts here at Index Engines. Today, I'm joined by Ed Moke. Ed has had 17 years with Index Engines. He served as our VP of Operations, and he's managed both the pre-sales, engineering, as well as technical support. He has over 45 years in the industry, building and managing QA, technical support, technical sales support, and all sorts of organizations. Bottom line for us, Ed is an amazing resource, and I'm really glad that he's here with us today. A little further bit on Ed. He spent about 23 years at AT&T and Lucent and Bell Technologies as they morphed into to different organizations. But he's been a great resource here, as I mentioned, at Index Engines. A little bit about Ed. He's a New Jersey guy. He and his wife have lived here for a very long time. And he loves to spend time with his four kids and and his eight grandchildren. So if he's not doing that, you can find him fishing. You can find him woodworking. We will ask you a question, Ed, on what one of your latest projects is in the woodworking mill there. And he also likes to golf and just really spend time with his family. So for all the viewers out there, please, just one quick logistical note. If you have questions, please use the Q&A function of the webinar. We are not monitoring the chat. So the Q&A webinar is the way to go if you would like to ask a question, and we'll see if those questions can make, if we have enough time, we'll get those over to Ed and we'll get an answer here. So without further ado, we'll kick things off, Ed. So where I'd really like to start is just the evolution of Index Engines, Ed. Can you explain a little bit about the CyberSense AI and full content, how the AI driven full content inspection capabilities really enhance not only data integrity, but enhance the ability to understand the true meaning behind a cyber attack?
Sure. Thanks, Rob. So I'd like to get started. I think it's to really understand what CyberSense is and how it's different than all the rest of the analytics that you see out there in the marketplace today is to really start from the beginning. Index Engines we've been around since 2004. Our founders, Tim Williams and Gordon Harris, really wanted to solve a problem back then about having search for the enterprise. You had Google to search for, to search across the internet, but there was no tools to search the enterprise. And so they wanted to have a technology to be able to solve that. And where were all the data from the enterprise? Instead of crawling out across the enterprises to find all the data was in the backups. Every night, data went into the backups. So they developed a technology. It's a purpose-built indexing technology, high speed, highly scalable, to be able to index and ingest, petabytes worth of data in a very short period of time. And then to be able to provide detailed keyword searching across that data, just like you can do across Google today. And that is really the fundamental technology of Index Engines, is content-based indexing. We've reverse engineered backup formats. We reverse engineered file formats. So we can not only get into files, we can get into backups, we can get into files as well. And we do this while the data is being streamed across the wire. This is not a store and crawl type of indexing. And it allows us to get to, be indexing at speeds of many terabytes per hour. In the case of CyberSense, we're seeing speeds upwards of 12 terabytes plus per hour, depending upon the application, depending upon what we're indexing. So this technology was used in the early days in e-discovery. So Index Engines was used by some of the big four, and other e-discovery houses across the world to be able to provide keyword searching. It was proven in some of the largest litigation cases in the last 10 or 15 years across the world. So it really was a true a technology that was proven in. We also used it as a governance engine as well. So not only backups, but we use that same technology. We could go out and actually crawl a production network and be able to index the files on the production network, to be able to index snapshots on that production network and get to the content of those files. So again, we've got a proven base architecture on which CyberSense is built. So how did CyberSense come around? Well, we were asked by one of our partners to say, can you look at data and tell whether it was attacked by a ransomware attack? We thought about that, and with the use of AI, so now what we've done is we've layered AI on top of that proven technology to be able to look at the content of the data, the bits and bytes, doing byte level analysis of the data within the backups or within a snapshot, and to be able to look at that data and how does that data change from observation to observation, from snapshot to snapshot, from
Right.
backup to backup, right? And does the content of the files of themselves change in a manner that's indicative of a ransomware attack? So again, we're looking at unstructured files. We're looking at database files, doing
Mhm.
deep level integrity checking of databases. Nobody in the industry does what we do for databases. Going into a database, understanding, looking at the header of a file. This is an Oracle database. We know once we know it's an Oracle database, we know the page structure of that Oracle database, and looking at and doing page level validations across that database, looking at the MD5 signatures of each page, calculating them during indexing time, and looking at the page allocation maps, making sure they link up. Deep level integrity checking of databases, of files, and looking at how that data changes from observation to observation. And does that data change in a manner that's indicative of a ransomware attack? If it is, we know the point in time of the attack, right? And that's the
Right.
key to starting out. When did that attack happen? And then understanding and going back and looking at the last observation that you may have had and analyzed, and did the data in that particular observation have integrity? If it does, that's your place to start with your recovery process. So really is a unique technology built on a unique technology, purpose built. No other company in the industry provides that. They're mostly backup companies. This is all bolt-on AI on top of their metadata. Nobody's doing content level indexing.
So, Ed, I want to build on that concept a little bit about specifically around AI. AI is being used not only by organizations such as Index Engines, but it's also being used by the cyber criminals as well to help develop and speed up new variants. Um, Index Engines, though, we're known for accurate detection of ransomware. We have a 99.99% SLA for ransomware detection. Uh, what makes this unique within our industry, right? Within the cyber recovery community, what makes this 99.99% accuracy level really unique to us? And I guess, how does it, kind of a compound question here for you. How does that help us and our customers really detect ransomware as it ever evolves, right? New variants are coming out almost on a daily basis. How can we keep up?
So well, I want to go where you started, right? AI.
Yep.
Um, AI is being used not only by folks like us and other companies who are using AI to detect ransomware. AI is being used by the cyber criminals themselves, whether they're using that to develop advanced variants. Hell, you can go on ChatGPT. I did it the other day and ask for a program to do partial base encryption of files on a Linux system. It gave me the program. They're using AI today to be able to develop new and more powerful variants um, for their cyber attacks. They use it for gathering data about what companies they should be hitting. Better phishing attacks. A lot of the pop-up chats you see are cyber criminals using AI in automated chats to try to get into that organization, right? Trying to lure victims into that organization. So
Yeah.
AI is not being used only to detection, but it's being used by the cyber criminals. So having said that, right, what we're doing is really different. So cyber criminals, when they detect it, when they're generating and attacking data, they can do one of three things. They can delete data, they can corrupt data, or they can encrypt data. And they can do that in many different ways, in many different combinations with many different technologies. There's different encryption technologies, some just raw encryption technologies that'll just encrypt data. And oh, by the way, that'll drive an entropy score. You'll hear a lot of vendors talking about entropy score. It'll drive the entropy up. But there's technologies out there that can encrypt data and not drive the entropy up. Very hard to detect, but CyberSense can detect that. So what we're doing is by looking at and so the key to AI is what data is your training, right? Well, how much data
Absolutely.
are you giving the AI to make a decision about whether there's an attack? All the vendors out there today, most of them are backup vendors. And what do they have? They have the metadata of the files, right? They have the file name, the file extension, the size of the file, when the files change. Some of them have and use real-time behavioral analytics, right? When the file was changed, how often the file was changed, and they use a combination of that in their AI. Very limited in terms of the number of data points that they provide to the AI and the ML engines behind them to be able to make that decision. CyberSense, on the other hand, because we're going into the content, we're using over 200 different statistics we gather during indexing time at the content level, that is then used to not only train AI, but is also used for the AI and ML engines to look at those changes, how that data changed from today versus previous changes, not just the previous change, but previous changes, and are those changes indicative of a ransomware attack? I think I answered you. Tried to address your question.
Yeah. And let's talk a little bit more about that training, because I think, from at least from Index Engine's perspective, this is really what powers, that 4.9's SLA. And it's really kind of the magic, if you will, behind everything. Explain a little bit about how, that extensive training can even detect some of these new variants.
So our training is unparalleled in the industry. I don't know of anybody doing the type of training we're doing in the amount of training. The 99.9% accuracy that we talk about is actually measured. And here's how our training goes, right? What we're doing is launching real ransomware variants in-house. We look and analyze ransomware on a daily basis. We've launched over 4,000 different ransomware packages in our lab today. So we start out with launching real ransomware, and then we use index engines, the content-based indexing, to then index that data, that data that we know was known good. We know what files there were, real files, not made up files. We look at how those files were changed for each different ransomware variant. And using index engines, the indexing technology, to be able to understand what ransomware is doing to data. We're generalizing and characterizing those different variants into really, it's about 36 different categories, different ransomware categories.
Mhm.
Because there's a lot of variants that do the same thing, use the same technology, they put a different extension on the file, or they wrapped it and they have packages that can infiltrate an organization a little differently than the rest, but the underlying attack technology is the same. So we're categorizing these variants. Once we understand how each type of category changes data, Now what we can do, because we've got the technology to do it, now we can go back and create data sets for training, right? And training is, here's a good data set. These are files that have good integrity. These are files that have been attacked in many different categories with many different file types, real world files. We're going out and getting real world files, files that change over time. And now we have the ability, because we know what ransomware variants do, we can now create files changed in those same manners with those same characteristics for each
Yeah.
different category and create backup sets. And we can do that automatically and manually. We've got a process to be able to automatically create real backups at a rate of about 1 million per day. So we create these data sets, good data sets and bad data sets, millions of them. And these data sets are backups, real backups. Now we start our training process. So now we take about 2 million of these data sets for the initial ML training, and we run Index Engines the training against that, so that it knows what's good and what's bad. Now what we'll do is we'll then validate, and that may have several iterations. We look at that after we train it.
Mhm.
We then go and use about 15 million data sets, different data sets than we use for the training. 15 million data sets, run Index Engines Cybersense across that, let it do its detection, and then look at the data. And that may be an iterative process. That may take 2 or 3 times to say, okay, I got this one right, I got all these right, I got these wrong. I need to go back and retrain. It may take 3 or 4 iterations to get to a point where I believe I've got 99.99% accuracy. Now that's just a validation of the ML. The ML is actually 10 different machine learning engines within the Cybersense. They all operate independently. And after they get done looking at the data, the 200 different data points from today and the 200 data points that were built from previous backups, then they do a polling to then go and generate one prediction of saying, does the data change? Is it the probability of an attack, is it great enough to raise an alert that the data changed due to a ransomware attack?
And so that
Then,
also helps us determine, just between general user behavior too, right? So user behavior like saving deltas to a particular file, right? You make some changes to, well, just a PowerPoint presentation or a PDF. That's considered normal user behavior, and those are you. We're not gonna raise an alert per se off of something as common as just a resaving of a file that has gone through extensive change.
no, because that's not any one of the characteristics that we looked at for what ransomware does, right?
Yep.
So we won't alert on those type of patterns. I just want to finish up here that after we validate on the 15 million, we do a final test on 30 million data sets, completely different data sets. So a lot of the data sets are actually data from real world customers. Our customers provide us with their analytics, not any of their core data, just the analytics,
Yeah.
those 200 data points. We get that on a daily basis. We have hundreds of millions of those data sets. We take another 30 million of new data sets. We run it across Index Engines. And at that point, we monitor, have we accurately detected ransomware with a 99.99% accuracy? If it meets that standard, that's when that code is actually shipped and put in a
Yep.
GA release. So 99.99 is not a made up marketing number.
Yeah.
This is a real world number that's been fully vetted and tested.
All right, you heard it here. I love it. So there was the part two to that question, Ed, is how do we keep up with these variants, right? We've seen spikes of variants that are that hit about 1,500 new variants released daily. So how does this extensive training of our ML lead to this AI that ultimately can help our customers?
So we've got an automated process where we're looking at new variants every single day. And there's roughly we look at roughly 850 new variants that are popped up across the dark web and wherever we get the different places we get our data, academia and various virus total and various other sources. But there's
Mhm.
about 850 new variants a day. We look at those variants, we analyze those variants. We don't necessarily launch everyone, but we analyze them and how they change data. We get that information um, from various sources, and we categorize them, and then we'll take samples from each category, new samples from each category, and then actually launch that ransomware in our lab, test it with the current version of our software to ensure that we do in fact detect those new variants. If there was any incidents where we didn't detect that, then we would go back into a retraining mode. But I have to tell you that that has only happened once in my career here since we started with CyberSense back in 2008 and 18 when the partial base encryption started coming out, and that really hasn't happened since. We do make some modifications, some improvements over time, but we haven't seen anything to date that really would cause us to go out and and reissue our code on an emergency basis. We're not looking for specific variants. Others, they look for specific extensions,
Right.
right? And that's just one of our 200 different analytics is what the extension is. Entropy is just one of 200 different pieces of information that our machine learning uses to be able to determine whether it's a ransomware attack.
So would you say that's a bit of a competitive advantage for CyberSense?
Oh, absolutely, absolutely. I don't think I don't believe any vendor out there today is testing at the level we're testing with the number of data sets or could create the number of data sets. We're using our own technology to be able to better understand ransomware, how it affects files, and then to be able to use that information to build work lists, to build
Mhm.
and build testing data that nobody else could do in the industry.
Great. Um, just a quick kind of follow, to continue down this AI road, obviously. But how do, we have a number of features that really help support our AI detection. And one of those is the CyberSense sensitivity index, and then also user-defined thresholds. So how do those enable organizations to help monitor and manage their particular data environments, especially in this high threat era?
So what we've done in recent releases was add the ability to actually see this, what we call cyber sensitivity, the CyberSense sensitivity index for each individual host that's being analyzed. You can now see this on the host page. You'll see the top graph is a CSI, and what that is the probability that an attack has occurred, right? And we'll show that probability, and you may see it flat, you may see it spike up a little bit, but when it hits the 50%, that's our default right now. When it hits 50% or better, then we'll generate that alert. So you can actually see that and track that for each individual host. By the way, that 50% mark still yields that 99.99% accuracy. With a 1 in 100,000 with 1 in 100,000 backups, there'll be a false positive, right? Nobody in the industry has
Yep.
that kind of false positive rate. You can't get that with just metadata only analytics. So we show that, but we also allow, if you've got a finicky host, you've got data on a host that doesn't correlate well with our training data, that may be giving you some false positive alerts and you want to tame that, or you got a host that you want extra sensitivity on, we allow you to actually change that sensitivity in that sensitivity for generating alert on a per host basis. We don't really recommend people do that unless they really know what they're doing and really understand what the results, what the impact of that changing. but it is there to change. We also, for each host, track the number of change files, the number of changed file types, number of deleted files, and the entropy of the files across that host on an ongoing basis every 30 days. And we've added the capability to, in addition to the CyberSense alert, to be able to add threshold-based alerting. Threshold either on across the entire host or thresholds down to a single file within a single directory on a host or a set of hosts. So now our customers have the ability to create custom alerts, custom thresholds if they want to monitor maybe gold copies of files. They want to create their own honeypot situation on a certain server, that sort of stuff. We've added that capability. You can see that they generate different alerts than the cyber alert, and so we've added that capability.
That's great. All right, we're getting ready to wind down a little bit here, but I'd be remiss if I didn't bring up recovery. So, how does the Index Engines AI-driven approach to cyber discovery, the discovery of ransomware, how does that ultimately lead to the accuracy, the speed, and adaptability of a company's ability to recover from a ransomware attack?
Okay. So first and foremost, with CyberSense, what you have is the confidence that the data that you're saving, whether it's immutable data, whether it's data in your vault, whether it's your snapshots that you're storing, you with CyberSense analyzing those, you now have a confidence that I can restore from any one of those backups. What CyberSense does is give you the point in time of the attack. If you're doing snapshot-based analytics and your snapshots are every 15 minutes,
Yep.
right? And I see a snapshot that data has been altered due to a CyberSense attack, I can look back at the last snapshot that I analyzed where the data had integrity. That's the snapshot I want to use for recovery. Same situation for backups. But the key here, right, is not, we had not just the ability to detect attacks, but also provide the confidence that the data that you may need to recover if you were ever attacked, you can recover from.
Yeah. I think trust, confidence, and speed are the combination of those really gives CyberSense a great advantage out in the marketplace. So I've kind of gone through all the questions that pop through into the Q&A. I tried to incorporate those into our talk today, Ed. I think we're good to go ahead and wrap this up. As always, and whenever I get to speak to Ed, I do learn something, and today was no different. I hope that everybody else listening today got the same from Ed. He is a wealth of information here at Index Engines, and a tremendous resource. We're really, really, really lucky to have him on our team. So with that, we'll sign off from this week's Ask the Expert, or this month's Ask the Experts, and we look forward to seeing you all at our next session. Take care, everybody.